Yesterday, I think we started about here. So we talked about what prompt engineering, RAG fine tuning is. Prompt engineering is just like explaining the model how to behave using verbal instructions. RAG is expanding the model's knowledge by adding a library. And then fine tuning is just additional training for a pre-trained model to make it better suited for a specific industry. Then we talked about the importance of foundation models, which is that like companies and stuff. Okay, so foundation models serve as a foundation for other more specific, bigger models, and also they're kind of general purpose. They can do a lot of things, so they're going to be really useful. And then we talked about all these different types of models there are, and use that as an example. And then we talked about how LLMs are again general purpose. They can now work with PDF, video, image, text files, Excel sheets, everything. And then we talked about how a modern LLM can be considered a foundation model, like ChatGPT can be a foundation model. We talked about buying versus making foundation models, which is better. And for bigger companies, it's going to be probably not as good because it's better if they develop the model themselves. But for smaller companies, uh, they will have to spend all the money to create the foundation models. So regular businesses buy from companies like OpenAI. And the thing that distinguishes these models that are bought are fine tuning, RAG, and prompt engineering. They improve the model's capabilities. Okay, so we talked about what Gen AI is used for, software development. So, coding, like generating code using things like GitHub Copilot. We talked about healthcare, maybe uh, diagnosing patients based on symptoms, surgical robots, maybe things like that. Then you talked about marketing, how uh, what's it called? AI gives you ads based on like what you like or like what you do on the internet or whatever. Then we talked about entertainment, where AI can sometimes be used to generate effects for movies, shows, video games, things like that. Then we talked about what embeddings are, which are just a numerical representation of data that capture the actual meaning of data in a way that machine learning models can understand and process efficiently. So an example of this would be binary, because computers can understand binary. We talked about what responsible AI is. We talked about minimizing the harm in transparency, fairness, the environment, privacy, and security, considering ethical implications, all of that. And this is about where we are, I think. Practical challenges in generative AI. Does anyone have any questions about yesterday?
Didn't we start like a quiz?
Yeah, but like I moved that to the end because it's a quiz, and I felt that you should like do it after you learn everything.
Okay.
Okay, so any other questions? Okay, then we'll start. So practical challenges in generative AI. So take ChatGPT, the model that everyone knows and that I've talked about like 100 times in this class. Well, in these classes, ChatGPT is brilliant, but sometimes we give it more credit than it deserves. Sometimes we can make mistakes, big mistakes, by not fact checking an AI's output. So by not, so because of AI's mistakes, we have to always be aware about that. And by not like fact checking what AI says, we might, you know, that would be a mistake. So for example, do you remember what happened last week in the neural networks lesson? The AI generated image of the crowd on the beach had many strange errors in it. Like the bundle of like limbs or whatever, like in an arrangement that made no sense. That weird speaker looking thing in the coconut tree, all of that. And This AI generated image of the crowd also had a lot of others, like other errors in it. For example, there was also confetti everywhere. I think something that looked like confetti at least. So you can also expect something like this to happen, no matter how small the chances. Even when talking to LLMs, instead of prompting AI image generators. This is what I was referring to when I was saying AI is never 100% accurate, and think I talked about this like 5 times or so, but this is what I'm talking about. It can also happen in things like ChatGPT, so you should always try to fact check your information. So, as a rule of thumb, try to remember the following principle. An expert works with AI and reasons with the AI conversation box rather than copying and pasting every answer and mindlessly trusting. So, you need to know like why AI made a decision to find. Okay, so if you think anything is like shady about like what AI gives you or like incorrect or anything, you can kind of just ask AI to like back up its conclusion or result or like its response to you. That is one way to try to figure out how it got to that. Uh, and if it's not able to give you something that makes sense, then it's probably incorrect, its information. But if it is, then you can move on to just fact checking it online. So, in fact, in the old ChatGPT website, if you look at the bottom of the screen, OpenAI clearly states that ChatGPT can make mistakes. Consider checking important information. So even OpenAI, like the company who owns ChatGPT, you might think that this would be like bad advertising and OpenAI would become unpopular, but they have to tell the truth. And no generative AI that we have right now in the current day is perfect, like 100% perfect. No matter how small the chances for them to make an error, they they could make an error. So you have to keep that in mind. Okay, so you can obtain two types of undesired behavior from generative AI tools: inconsistencies and hallucinations. Okay, so hallucinations first is what we'll talk about. I don't know why we're going right to left, but it's whatever. Hallucinations are observed when the AI provides false output to generate any production. Since I've already taught you last week how generative AI, specifically LLMs, operate, you realize that models often predict the next word in a sequence using the previous, like preceding context to enhance accuracy. If you don't remember me teaching you that, just ask whatever questions you have about this, and I'll be happy to answer them. Just any questions you have about anything that you learned in these classes, just always remember that you can ask questions and I'll clear your doubts.
So, for example, like for the inconsistency and the hallucination one, like let's say the AI that you trained is like, let's say it's like ChatGPT, and you trained it to do like everything. So let's say you ask it to generate a picture and it's really good at that, and then you ask it to give you an answer for your English homework or something like that, and it's not good at that. Would it be like an inconsistency?
Oh, inconsistencies. I'll talk about that in a second, but it's not quite like that. Inconsistencies are different and they usually like involve the same exact type of like prompt or whatever. So images and text, like they're completely different. It wouldn't fit into what I'm talking about. But that would just be like a consequence of bad training, maybe. Like you didn't train the model to properly like understand text data while you did for image data. Your neural network might not be suited for that, its architecture. Those are more probable causes of what you said happening. So I'll talk about what I mean by inconsistencies in a second and how that relates to your question. But anyway, uh, despite the power and sophistication of these models, these LLMs like ChatGPT and so on, their predictions can occasionally be incorrect. Another reason hallucinations could occur is that the AI could be trained on factually incorrect data to begin with. So, if you remember me talking about the 7 phases of LLMs, like I think the class before last class, yeah, then I said an AI model is only good as the data used to train it. And I mean, that's not entirely true technically, but like it's pretty close to true. Like if you have no data to train an LLM, it's not going to be able to do anything at all. If you have bad data, it's going to give you completely incorrect information. But if you have good data, then it's going to work as intended. So data is very important when manufacturing an LLM. But in general, just any generative AI model. Okay, so that problem in the data, like maybe not having enough data or maybe not having the right data that's factually correct and everything, that could be a problem that causes hallucinations. If trained on false data, the model will most likely produce incorrect outputs, right? So again, this shows the importance of the data set engineering phase. If you don't remember what that is, you can ask a question, but it's just basically what I just said. Engineering and like getting the data that you need to train an LLM. So, do you remember when we did that activity? Like, I think that was also the day before yesterday, but it was when we like trained the model on that Teachable Machine website. We used car images, flower images, lion and tiger images. So, when we trained the AI on a low amount of data, with the tiger and lion, it was obviously like not very accurate. It said the tiger looked more like a lion than a tiger, which kind of makes no sense. So we trained it on a low amount of data and it obviously performed very, very like bad. Uh and when we trained it on like uh let's say we trained it on like a data set of cars and then we asked it to recognize a lion. It's obviously not going to perform very well. It's like it would give its best guess, but it definitely wouldn't be sure of anything. And you need to have data that is actually like suited to the industry you're working with and that will actually come in handy when the AI is doing whatever operations it's doing. So a legitimate tactic for dealing with hallucinations is to give an instruction that says provide an answer only if you know the answer. So if the AI doesn't know the answer, okay, wait, during like a testing phase or something, you could ask the AI a question and then add this like sentence onto your question, provide an answer only if you know the answer. And then if the AI doesn't provide an answer, you know something's wrong with the AI and you have to fix it. But if it correctly provides your answer, you can test it multiple times. And it probably means your model is good to go, although it should undergo lots of rigorous testing. But yeah, this is a legit like a good tactic for dealing with hallucinations. It doesn't exactly tell you what the exact problem is in your AI model, but at least it tells you there's a problem, which is obviously very useful. So in some cases, this type of prompt engineering, so provide an answer only if you know the answer, that could be very helpful. Okay, so now that's hallucinations, and now I'm going to talk about inconsistencies. Okay, so on the other hand, inconsistency occurs when a model provides very different responses to the same question. So Kashyap, you asked about like an image generation thing and text prompts. You can't really like apply inconsistencies to that because it has to be the same type of problem, the same exact question. If it's giving different results for each session, then that obviously means that there's something wrong with the AI. So for example, if you ask ChatGPT, what is 1 + 1, and it first says it's 2. That's correct. When you ask it again, it says it's 3. That's pretty weird. And then you ask it again, it says it's 1. It's obviously something's wrong with it because that's not supposed to happen. And you could use that type of like prompt engineering sort of thing also to uncover these inconsistencies. Okay, so especially when ChatGPT first came out, it actually felt like the AI was smarter in specific sessions and dumber in other sessions, according to users and like OpenAI themselves. Obviously, since it wasn't trained well, like on as much data as it is now, it wasn't very sophisticated as it is now. But that's still pretty advanced for generative AI. So even with like some very advanced and powerful LLMs, you can never really expect it to be 100% accurate. You're probably likely to see both inconsistencies and hallucinations to this. Okay, so this is actually due to variations in the hardware used to run the model or other uncontrollable factors, primarily when the model is hosted or stored externally in the company's hands rather than in the users. So let's say ChatGPT is like run by the what's it called? Yeah, like run by OpenAI, and all you have to do is like open an API call, which is just a request to do something or use something. So all you have to do is just kind of ask OpenAI to use ChatGPT, and it's going to run it for you. So if there's a problem there, then you're going to see problems like for whoever uses ChatGPT. For example, if you ever use ChatGPT and like it says it's down or something, it's most likely because OpenAI has like an error in their thing. But if if it doesn't say it's down for like other people who are also using ChatGPT simultaneously, you know it's something with your processing system. There's a little bit going on between both. Okay. So uh one unproven way, like it's not very reliable, like I just said, it's unproven. You don't know if it's going to work, but one unproven way to reduce inconsistency is by instructing the AI model to take its time to come up with an answer. People are not sure if this is like again valid, if it works every time. But hopefully, if you do that, it won't rush to produce a response, and the system could allocate more hardware resources for every prompt. So the like the more time a computer has to process, the more like slow and steady and like accurately it's gonna do it. But in like the current day, a lot of people don't really have much patience for like loading times that are really slow and stuff. So we ideally want to avoid that when creating an AI. But in any case, detecting hallucinations and inconsistencies and finding ways to deal with them will be one of the major topics of AI research in the years to come, and will surely make a market worth billions. Like, nobody's figured out how to completely make AI 100% accurate, and these are like the two issues. If they figure out how to do this, they basically made the perfect AI, which is going to be an enormous breakthrough, and that could lead to strong AI. If you remember at the very beginning of the classes, I talked about weak versus strong AI. Strong AI is supposed to be perfect at every task, every single conceivable task, do it better than humans. So that would be the first step towards it. Okay. So next, budgeting and API costs is what we're going to talk about. This next short topic kind of thing. But for pretty much all AI models and for LLM specifically, the two primary factors that determine the power of an AI model are the data set and the model size. A larger, higher quality data set significantly enhances the model's learning potential. Like I told you earlier, a model, and again, this is not completely true, but a model is only as good as the data used to train it. So again, you can see how critical data is. And meanwhile, the model size, that determines its learning potential. Think of the large data set as a library full of books. All else being equal, the more high quality books we have in the library, the more you can learn. So if you have if you're learning off of books for toddlers, that's obviously not going to be very educational for you. You're not going to learn anything. But if you learn like from actual textbooks and stuff, or like things that fit your learning style, or things that are meant to be educational, you'd probably learn it like at least a little better than from toddler books and stuff. So think of the large data set as this library full of high quality books. When it's a good data set and when it's a bad data set, it's going to be like a bunch of toddler books that are like nursery rhymes and stuff. So in this analogy, a model's size can be compared to a student's learning capacity. So let's say a student is learning off of these books. Students who can remember and internalize more information can use this extensive library. And extensive library might remind you of RAG, but this isn't exactly what it is because this is just the data that you get with the model. But yeah, like students who can remember and internalize more information can like properly use the library. So if you have very good data that's like exquisite, top of the line, is like super sophisticated, would probably make your model the best in the world. If you don't have a neural network that's capable of processing and understanding that data, then you you're not gonna have a good model. That's like having I don't know, like a book about rocket science in front of you and saying that if you understand rocket science, you'll become the richest person in the world, but you're just simply too dumb to understand it. That would be the case with an a model that has a poor neural network architecture and model initialization with a great data set. So both are pretty important, as you can see. And similarly, a larger AI model that has more parameters will be able to capture more intricate patterns and make more complex decisions based on the information learned from the data set. So last class, I think I already told you what parameters means, but it's like those little variables, those little sliders that you can change to adapt or like uh, affect the outcome of the AI model. So in general, the larger the AI model's dataset and model size, the higher its performance can be expected. But building the largest model isn't always the best strategy because it involves a clear trade-off between the performance and cost efficiency. So it's expensive to acquire large, high-quality datasets, and even more costly to set up and purchase the computing power to train a considerably large model. So if you remember last week when I talked about the history of AI, I told you how back then the limit on AI, the cap, really was computational power. The computers back then and the CPU, like it wasn't that strong, that sophisticated, and it couldn't really run powerful AI that efficiently. That's part of the reason why AI was so unpopular back then. Not just because like the people there hadn't thought about AI yet in the way that we did. They certainly have probably, but they just weren't able to do it. And so with time, that has been fixed. Okay, so anyway, I told you how it's expensive to acquire these data sets and get the computing power to train a considerably large LLM or large language model again. So you can see that budgeting is a crucial topic and a fundamental skill AI developers must acquire. You can't start building your AI model and then figure out how big it will be and how much money it will cost during the training process. That's like being half okay, so that's like going to an art class, drawing something and being halfway done with the drawing before you even know what you're drawing. That would be pretty ridiculous and kind of dim. Why would you do that? But that is exactly what like refusing to budget and then figuring out how it like how your budget is going to work while you're creating the AI model. So you can't start building your AI model and then figure out how big it will be. Instead, it's much bigger to consider the available budget beforehand and decide what portion will be allocated to data acquisition and computing power. So this aspect is actually quite tricky for most developers and people. And OpenAI spent $100 million to train ChatGPT, which is a lot of money. And this is just training ChatGPT. Like how much would they have to pay to like their developers and stuff and like all the other costs, maybe advertising and those firms that they have to sign with the big tech companies. These firms and stuff we'll talk about like in like 5 to 10 minutes probably. And we'll get to that. But the point is, just training ChatGPT took $100 million, which is a lot of money, obviously. So OpenAI is like the AI organization in a lot of people's minds, like super sophisticated. They have like ChatGPT, which is like supposed to be the craziest AI, and it kind of is right now. But most organizations and most organizations are pretty like small. They're not as like sophisticated as OpenAI. These organizations, they can't afford multiple attempts at training their AI models. OpenAI has trained like GPT-3, GPT-4, GPT-5, and it has retrained these individual models multiple times when the results weren't as expected. So it was kind of like testing and troubleshooting here. But most organizations can't do this. So they have to succeed on their first try, finding the right balance between how well an AI performs and how much it costs. This is really critical because if you blow it on your first attempt, you're probably not going to get a second chance for these smaller businesses. So this is key to AI development. Bigger AI models need more computing power during training and operation, which can get expensive. Creating a large model should hinge on a significant boost in effectiveness that aligns with an organization's goals and resources. In some cases, building smaller AI models that can be retrained and fine-tuned frequently actually makes more sense because training smaller, more specialized models is more cost effective because you don't have to train it on nearly as much data. You don't need nearly as much computing power either. And it's faster than using vast resources to train a large model for limited applications. Okay, so that is budgeting and API costs. This is another setback in or challenge in creating generative AI. Next, we have latency. Okay, so one key issue when building customer-facing applications is that today's users, like I said, have a very low tolerance for slow loading times. Like back then, for computers to work, it might take like several minutes for them to do a simple mathematical calculation, maybe. But in the current day, if you Google what is 5 plus 6 or something like that, and then you have to wait like 5 to 10 minutes for the result to come, you would probably be quite disappointed. You wouldn't be happy at all, since you could literally like do that obviously in your head a lot faster than like waiting all that time for AI to give, I mean, for Google to give that answer to you. That is obviously a big problem. So, um, most organizations and stuff, they try to solve this. Like for Google, if you actually search up what 5 plus 6 is, the answer will come like within like 3 seconds, which is pretty fast. With the loading of the new tab and all those different websites on the internet and everything. But this latency issue becomes even more critical when business customers want to use AI to boost personal productivity or build products based on an AI model. In such scenarios, the stakes are higher because delays frustrate users, because we have a very low tolerance for them, obviously. And they frustrate us, and they also directly impact business operations and revenue. So if a company can't like process things as fast, they're obviously not going to get money as fast either. So the faster you are, the faster you earn money, which means the more money you get in a shorter amount of time, obviously. And these business operations and transactions and stuff, they could slow down too, which could be a big problem for the business, may cause some misunderstandings or errors, things like that. So as you can see, latency is like an enormous factor. But regarding latency, the biggest challenge of LLMs today is that the models use an autoregressive architecture, which if you remember what well, I mean, autoregressive models are from last week, they essentially just predict where each word generated uh, depends on, okay, so they just predict where the next word is. That okay. How do I explain this again? if you have a sentence, so water freezes at like 0 degrees Celsius, like the example we used last week, uh, you have the words water freezes at 0 degrees, and then the AI model has to generate the next word. The most probable answer for that is Celsius because it's pretty well known that water freezes at 0 degrees Celsius. So AI would fit that in, and it just predicts the next word based on the preceding words and context that is previously generated. So the sequential nature of this going word by word, step by step, waiting for each word to be generated, this actually limits the speed at which outputs can be produced because each step must wait for the previous one to be completed. So like I said, ChatGPT is an autoregressive model, but you might be confused because it's actually not all that slow. It's pretty fast, but I'll talk about it. So if an LLM sequentially generates one word in a sentence, my favorite sport is basketball, at 0.2 seconds per word, it would take 1 second to complete the sentence. So imagine an LLM like that had to write a whole paragraph, several paragraphs or something. If literally 5 words would take a second, several paragraphs would take like minutes. Well, it would just take a long amount of like a lot of time. So to solve this time issues, these time issues, AI developers are exploring different architecture types of neural networks and maybe even like inventing new things, new techniques, and parallel computing, which is just like doing two things at a time, sort of, which kind of goes against the whole autoregressive model sort of thing. But at least they're trying to find an issue for it, so that's good. But an effective immediate strategy is to optimize the model size. Okay, so smaller models are often faster than their larger, more complex counterparts because of the lower computational power required, which in turn lowers the computing time. Also, they're trained on less data, so they have to process less information that they have. So in general, it's just a lot quicker. So in this case, think of it as the rabbit and hare story. Slow and steady may win the race there, but wait, no, not the rabbit and hare story. The hare and turtle story. What am I saying? Anyway, like I said earlier, today's users have low tolerance for slow computing time. We don't want like 5 plus 6 again to take like 5 minutes to load on Google, since that's just ridiculous. But Uh, in this case, think of it as a different type of race. The smaller one goes faster, the smaller model goes faster because it's lighter, and the bigger one goes slower because it has a whole lot more weight and it just can't carry itself that fast. The bigger one may be stronger, like LLMs are, but the smaller one is still a lot quicker. So that's the thing. So the pros of small models are they're a lot quicker, but the thing is they're not that strong. They might not be as accurate, as sophisticated as larger models, which are very knowledgeable, very like accurate and stuff, but they're not the fastest, of course. So again, don't think of it as the rabbit and hare story, the rabbit and turtle story, where slow and steady wins the race. Because with a fast and small AI model, like the rabbit, we're not gonna like sit in some tree for some reason and just like wait for like 5 minutes and wait for the larger AI model to cross us. Obviously, if you were the smaller AI model, why would you do that? That's kind of idiotic, but uh, that's not the case here. So that's one thing. And in this case, you can think of the heaviness of the model that I was talking about. The larger models are heavier. You can think of that heaviness as a flexible number that is determined by the model's complexity and the data used to train it. So the neural network architecture could also be a big like factor in this, and the scale of the data it's processing, and the number of tasks it can do and everything. There's a lot of different things like that. Okay, so next we have the last practical challenge of AI for now, I'm pretty sure. But this is running out of data. Can we actually say running out of data? If you remember how, like how I was talking about last week, about how the data necessary for training generative AI is expanding rapidly as time goes by. I told you that GPT-3 was trained on 175 billion parameters, while GPT-4 was trained on over 1 trillion, and GPT-5 is likely to use even more. So when we see this trend, it's natural to expect that the next version of an LLM will be significantly larger and more sophisticated than the previous one. But one major issue is likely to hinder this process, and that's running out of data. You may not grasp what that means right away, but don't worry, I'll explain it. So let's say that GPT-4 has already read and processed a significant part of publicly available data on the internet, which it has. Then where would the new data from the GPT-5 come from? Looking at the ratios between GPTs and predicting the trend, GPT-5 should ideally use like over 7 trillion or so parameters. But where will all of those parameters come from? We need somewhere to pull the data from, of course. So even the internet, which is as big as it is, people are worried that they might not find the data they need there to train their AI models, especially OpenAI. AI developers risk running out of data and face a potential showdown in the growth of AI model capabilities. If you have less data and you can't like grow as fast with the data, the growth of AI in general is just going to be like very decreased. It's not going to grow as fast either. So people are just like scourging the internet for data, looking for whatever they can find. So that's basically the case here. But moreover, now that ChatGPT has gained popularity, there's a significant risk that many of the new articles and materials online on the internet will actually be written using ChatGPT. So all those medium like newspaper authors online off of those not so trustable websites, it's possible that an AI model could be trained on that, and it doesn't really make sense when those articles could be written by AI. What sense does that make? This is quite the interesting case, because what good comes to ChatGPT if it's trained on the same information it generated? Moreover, what if that information was wrong? ChatGPT would be strengthening itself on factually wrong data that it wrote, which would just make the problem that it already has even
I have a,
worse.
I have a
Huh?
question.
Yeah.
So essentially, what you're saying is that if an AI is trained on its own data, it's not going to have any more effect.
Yeah, and it actually could potentially have a bad effect. So let's say that ChatGPT was trained on the fact that it wrote and it said that 1 + 1 is 3, which is obviously wrong. But if someone on the internet found that and was trained on that, that belief sort of thing would actually be strengthened and more like rooted into the AI. So it wouldn't really make there not be any changes. It would make the AI less accurate, which is obviously a big issue. So we need to find actually factually correct data for models to train on. So this would be a disaster, obviously. But the risk of articles being written in AI makes learning new information challenging for future LLMs because they frequently encounter repetitive or derivative content on the internet. So further models will simply echo what previous models have written, thereby increasing the risk of hallucination, like I talked about earlier, and biases too, also inaccuracy. And another obstacle to this availability of data is that following the hype and everything surrounding generative AI, like pretty much everyone knows about it. So pretty much everyone knows about it and anything. Um, Several large organizations around the world have actually filed lawsuits and prohibited data scraping of their websites because they want to keep their information private for their own reasons. I don't know why. It depends from company to company, but they have actually filed lawsuits and made it like illegal for AI models to train off of their data. So this means that the few people who have the private data or proprietary data that models haven't used to train on um, are marketing their data off bounds to generative AI, which of course is a big obstacle to data availability. So like the few good data that is left, because the internet obviously does not always have factually correct data. You can't always trust the internet. like the little data that is accurate right now, even if that like even that's being prohibited, which means there's almost no hope for generative AI, right? Because even the final processes, well, no, the first process of the first processes of legal action came from the New York Times, Shutterstock, and best-selling author John Grisham. So while platforms like Reddit and Quora changed their policies to make it illegal for AI developers like OpenAI to scrape their platform data, which is pretty ridiculous because AI and Quora obviously have a lot of information. I'm not exactly sure why they would make it illegal for AI to train off of their data, but that's how they made it, and that's a big issue because those are like really enormous domains in the internet. So to mitigate this issue, OpenAI has actually found a semi-solution sort of thing. They actually started a content licensing program and has already signed agreements with several organizations that own some of the largest proprietary or private data sets in the world. So OpenAI offered publishers between $1 and $5 million a year to access their archives and proprietary data to train its generative AI models like ChatGPT. They signed deals with organizations like Shutterstock, Axel Springer, the Associated Press, and Prism Media. In the future, competitions between tech firms developing LLMs will likely significantly increase the price of large proprietary datasets. Okay, any questions about these practical challenges of generative AI? It's a lot that I talked about, but does anyone have any? All right. It doesn't seem like anybody has any questions, so for this practical challenges, like I'm just gonna quickly like summarize what we learned, like just in case you're confused on any of it or anything like that. But there's inconsistency and hallucination. Inconsistencies are where you see like incorrect answers in like the same question but just in different sessions, which means it's not consistent with its training data or like the facts that it has. Hallucinations refer to AI models like giving responses that just don't make sense, they're incorrect, even though they may seem true. And a way to avoid this maybe is to just only say the answer if you only know what it is, like I told you about earlier. It's not always effective, but
Excuse me.
uh-huh.
I just went to the restroom. Did I miss anything important?
Where did you leave off? Like, what's the last thing you heard me say?
Well, when I just walked inside the restroom, I heard you say of something about 5 million.
5 million? Oh, okay, okay. I think I know where I am then. Wait, when you walked into the room or when you left?
When I just left. The
Oh,
last
okay,
word.
then I know where we are. Okay, so I'll just start from there real quick. So I'm pretty sure I was talking about. Okay, well, anyway, like we were nearing the end when we were talking about that. But to mitigate the issue of like companies prohibiting their data to be trained, OpenAI has started a content licensing program and has already signed agreements with several organizations that own some of the largest proprietary and private data sets in the world. So OpenAI gave its publishers between $1 and $5 million a year to access their proprietary data archives and train its generative AI models like ChatGPT. They signed deals with organizations like Shutterstock, Axel Springer, the Associated Press, Prism Media. If you haven't heard of them, well, that doesn't really matter. They're organizations, but it doesn't really concern you for this class. But in the future, competitions between tech firms developing LLMs will okay, wait. Competition between tech firms and developing LLMs will likely significantly increase the price of large proprietary data sets. Did someone say something?
I think it was Kasha.
Okay. Well, it was probably an accidental unmute, so it's whatever. Like it happens all the time. But now, Kashyap, you asked about the quiz earlier, so now we are officially done with like all the content. I have a small activity at the end of class if we still have time, but for now we're just gonna do the quiz. Okay, so you already did the first question. Which of the following best describes generative AI? Can everyone type in the chat what they think the answer to this question is? And private message me if you can, by the way, or if you know how to private message me. But you get the point. Take your time with this question. Okay, Driven, you're right. Nice answer. Kashyap, you're right. Nice answer again. Okay, Abhik answered, and yes, you're right. And answered, and you're also right. Message, you're also right. And Savik message A, so that's correct. Okay, so what distinguishes generative AI from traditional AI? If you don't remember earlier, we talked about the difference, and generative AI can create new data. It's meant for creating new data, like that's its sole purpose pretty much, while traditional AI only processes existing data. Answer choice B says generative AI is only used in robotics, which is completely false because people even use ChatGPT when cooking and stuff. While traditional AI is used in software programming, if you chose this as your answer, which thankfully nobody did, um, I don't know where you got this from, but yeah, it's whatever. So C, generative AI needs a lot less data to work properly than traditional AI. This is completely false. Earlier, I told you that ChatGPT requires 570 gigabytes of data to work with. And to be fair, I didn't tell you how much traditional AI needs to work with, how much data, but I didn't explicitly state this anywhere, so it it could be an okay guess, but it's not the right answer ultimately. Answer choice D says generative AI operates on fixed rules, while traditional AI works with neural networks. This is literally the opposite. Generative AI works with neural networks to create new content. Traditional AI operates on fixed rules. Okay, can everyone type their answers in the chat? Private message me, by the way, for this question. What best shows how AI, ML, and deep learning are connected? Take your time, by the way. Also, the hierarchy stuff can be kind of like confusing. You might like mix two terms up. I don't blame you. Like, I don't expect you to be 100% accurate with this. Message, yes, you're correct. And Satvik, yes, you're correct too. Yeah, yeah. I got it, Nirvin. You're right, you're right. Okay. Love you. Okay, you're correct. Take your time with your answers, by the way. Don't be like, like scared to answer anything. And if you don't know the answer, you can just simply tell me in the chat. Okay, Kashyap message B. Oh wait, I just said it. Okay, now there's not really any point in like me waiting for everyone because I just said it on accident. But Well, now you know the answer. I won't do that next time, hopefully. But what best shows how AI, ML, and deep learning are connected? If we go back oh, all the way to the beginning, like we go to this slide. Okay, AI. So at the innermost part comes DL, so deep learning, then ML, then AI. So which has that here? So deep learning is a part of ML, ML is a part of AI. That should be your answer. Shows how this is connected. Yeah, here you have the exact answer. ML is a part of AI and deep learning is a part of ML. Here it says AI is a part of ML, which is the first thing is also like completely wrong. AI, ML, and deep learning are entirely separate fields. This is also wrong. They're all connected. Deep learning is not, well, I mean, deep learning technically is a part of AI, but ML is not a part of deep learning. It's the other way around. So B would be your answer. Okay. Which of the following is not a capability of generative AI? Just type your answers in the private chat. Take your time if you need to. Josh, hope you're right. Dylan, you're right. We're getting some fast answers. Ethan, you're right. Avik, you're right. It's not very like too difficult. Yeah, Dylan, you're right. I understand. The answer to this, by the way, it's obviously all right. Like just tell me and I'll explain it to you. Just type it in the chat if you don't know what it is. And also, if you don't know what it is, like don't be embarrassed or anything. Like I won't call you out either. I'll just straight up explain the question. Yep, you're right, Tanu. Okay. All right, let's discuss. Okay, so which of the following is a capability of is not a capability of generative AI? And for this example, you can use ChatGPT as an example. So generating human-like text responses, this is definitely correct since like, you know, LLMs are a type of generative AI and they are meant for like working with human text. Uh, I mean, human language in the text format. Translating languages, I told you LLMs actually do have that capability. Uh, Summarizing long documents. Okay, now this, if you ask ChatGPT to like summarize a page of work, it actually could do that. Um, I never said it couldn't do that, after all. And D, guaranteeing 100% accuracy in all responses. I've said this like a lot of times that AI can't be 100% accurate, especially generative AI, and even like in ChatGPT at the bottom. It's like OpenAI themselves said that ChatGPT can make mistakes. Make sure to fact check your info. So D is the correct answer since that is not a capability of generative AI. It cannot currently be 100% accurate. Maybe someday, but that's definitely not today. Okay. Can everyone type their answers in the chat to this question? Like one more question after this at most if we have time. Savik is right. Okay, Abhik is right and Tanu is right. Oh, wait, I had more answers here. Yeah, Kashyap is right and Ethan is right. Okay, so has everyone answered? I think everyone has answered. Okay, anyway, what is one primary feature of ChatGPT? A, generating entire albums of new music. This is not the primary, like one primary feature of ChatGPT. People like don't use it to generate entire albums of new music like that commonly. I mean, I guess it can like maybe be done like I don't know. I'm not even sure, but that's not the answer. I mean, technically, for like maybe one person out there that could be right, but not for us. And performing complex mathematical operations, this is actually not true. Like generative AI is not good at math for some reason. Like in basic mathematical operations, it's good at, but it wasn't like built to do this at all. It's just mainly meant for generating new content, not meant for computing this. Okay, C is engaging in human language conversations with others. ChatGPT is an LLM. The primary purpose of an LLM is to engage in human language conversations. So this would be a great answer, and that also is the right answer. So C is the correct answer. Lastly, we have D, driving vehicles like cars, ships, helicopters, etc. Have you ever seen ChatGPT like as a car driver? Because I don't think that would be very accurate or like very realistic. This is like the most ridiculous answer. If you chose this, then that would be quite interesting. But yeah, you know the answer. And okay, actually, I did like plan a lot more questions for you. Oh my God, there's a lot. But anyway, the point is that um now that we're done for class, does anyone have any questions about the entire 6 days? All right, no questions about the entire 6 days. So if I randomly called one of you out and then asked you like a tough question, would you be okay with that? I don't know, I'm just teasing. But like for the most part, it does seem that like y'all learned well about the content. Oh well, there's a lot of questions. But I guess that's it for today.
Let's all
And
thank Supra. This is an
yeah,
amazing
yeah.
class that he did. Put it all
Thank
together.
you.
It was very, very deep content. I learned a lot too. It was awesome.
Yeah, thanks.
Thank you.
And
Thank you.
yeah, thank you all for listening, of course.
Thank you.
Yeah. Bye.